Alright, so I wanted to show you this practice problem. A chemist measures the amount of hydrochloric acid in pure water at 25 degrees Celsius to be 3 times 10 to the negative fourth molar. Calculate the pOH and the pH. Is the solution neutral, acidic, or basic? Okay, so for this problem, there's a couple pieces to it, but the most important part is the autodissociation of water. So we have a concentration of HCl is equal to 3.0 times 10 to the negative 4 molar. And remember, HCl is a strong acid, so this is a strong acid. So because HCl is a strong acid, it dissociates completely in water. So we can say that this concentration is going to be equal to our H plus concentration, or actually our hydronium ion concentration. So we can easily calculate the pH because we can say that the pH is equal to the negative log of our H plus concentration. So if we take the negative log of our H plus concentration, that's going to be equal to roughly 3.5. Okay, so there's a couple of things that we can do here. So we know that that water has this equilibrium expression that it autodissociates to H plus hydroxide ion. And so we call the equilibrium constant Kw equal to H plus times hydroxide. And so there's a couple things we can do. We could solve this problem a couple of ways. We could use this expression to plug in our H plus concentration and solve for hydroxide. So the way that we would do that is we would say that hydroxide is equal to our Kw divided by H plus, or we can use the other expression that we learned today in class. Since we're trying to find pH, remember we said that pH plus pOH is equal to 14. And we derived that in class, and if you need to convince yourself of that, I would suggest doing that. So we already calculated that our pH is 3.5, so our pOH is going to be equal to 14 minus our pH, which is equal to 14 minus 3.5, which is equal to 10.5. Alright, so this is just another example of how if we know the known concentration of H+, we can use our Kw expression to find our hydroxide. We could do the same thing if we knew hydroxide. We would know H+, because this is an equilibrium constant. So as H+ increases, as that goes up, OH must go down, and vice versa. If hydroxide ion concentration goes up, if we're in aqueous solution, H+ will go down. And then the very final part of this problem is that it asks us if the solution is neutral, acidic, or basic. Okay, so we know that our pH is 3.5. And remember, if pH is lower than 7, then this is going to be considered an acidic solution. So we'll just draw a box over acidic.